All right, let's look at the homework 3.8, problem number 7. All right, let's do this Newton's law of cooling problem. All right, so it says that coffee is initially 95 degrees Celsius. So you have this is going to be our T0 value, right? And in a 20-degree room, so this is going to be the temperature of the surroundings. So this is going to be T sub S. All right, then we have this a clue to find out the K value. It says that when temperature is 61, cooling rate is so temperature. So if when T is equal to 61, cooling rate is so it's going to be dT over dt is since it's cooling, it's going to be -1 because it's it's decreasing, right? All right. So then we want to find let the y equals t minus t sub s. So you can see that the dy over dt is actually exactly the same thing as dy over dt is really the same thing as derivative of, say, t minus t sub s, right? But the t sub s is a constant, derivative is going to be 0, so dy over dt is exactly the same thing as dt over dt, right? And then we know that this is proportional to the difference between the temperature and the temperature of the surrounding, right? So we have that. All right, so let's use this equation to find the K value. The K value is going to be, so it says that the temperature difference, actually not the temperature difference, the cooling rate is -1. So I'm going to put -1 for dt over dt, and K we don't know, right? When T is 61, so we put 61, minus temperature of surrounding is 20. So this is going to be 41K. All right, so we can just divide through by 41 to get the K value. So -1 over 41 is the K value, right? So we found -1 over 41 for K. All right, the A value is, this is just the initial value. So it's same thing as, so A is really the same thing as y of 0, which means that you're going to plug in 0 for t, so it's a t0 minus ts, but the t0 is just 95 degrees minus ts is 20. So it looks like it's going to be 75. All right, so we have 75. All right, so let's type that. Oops, sorry. Let's type it in. All right, we have 75 for A, and the K value is -1 over 41. All right, let's check the answer. All right, I came back and looks like we got the first two parts correctly. All right, so last part. After how many minutes is the temperature of the coffee 61 degrees Celsius? All right, so we just have to set the temperature function equal to 61. All right, so the temperature function T of T is equal to, right? So T sub S plus T sub 0 minus T sub S e to the kt. And since we know all these numbers, so I'm going to just go ahead and put in T sub S is 20 plus T0 minus TS we just found out to be 75. And then we have e to the k is -41, so negative T over 41. All right, so we want this temperature to become 61, so we set it equal to 61. All right, so let's isolate T. First, I'm going to get rid of this 20 by subtracting 20. So you have 75 e to the negative T over 41 is equal to 41. Right? Then we get rid of 75 by dividing through by 75. So we have e to the negative t over 41 is equal to 41 over 75. Actually, I'm going to go ahead and take the natural log too. So I'm going to apply natural log to both sides of the equation. Right? Then you can see that natural log and exponential functions are inverses of each other. They basically cancel each other out. So you have a negative t over 41 is equal to natural log of 41 over 75. Right? Then we can isolate t by multiply by negative 41. So we have a t is equal to negative 41 times natural log of 41 over 75. Right? Let's compute this using GeoGebra. I'm going to open up a GeoGebra here. All right, so let's see, type in, we have negative 41 times natural log of, we didn't really need to put the times there, 41 over 75, right? So it came out to be 24.76, so 24.76. All right, let's type it in. All right, 24, oops, sorry, here. 24.76. All right, let's check the answer. All right, I came back and looks like we got the last part correctly as well. All right, that's it. I hope that this was clear.